So we've been chit-chatting about quarantine, and it's just getting bad. It's kind of a pain. Again, like Brody, like you said, there's nothing we can do about it. I mean, if they tell you that you got to go home, you can't argue. Like, you can't show up and
what would they do if you showed up?
I mean, I would have to report, like, hey, I have a kid that is on quarantine, but he's in my class, and they would literally come get you. Like, either the nurse or the principal's like, don't go that route. It's not worth it.
Would they bring the police into this problem?
I don't know. I mean, that's real bad. I mean, yeah, don't deal with that. Like, don't refuse the nurse and the.
I ain't going down without a fight.
I'm not refusing anybody.
You just.
So the one thing that I want you to keep in mind is that they're not trying to make it hard on you by sending you home. It's all about a safety thing, because the school has a lot of responsibility to take care of you. That's one part of a school's role, is to take care of all of you while you're here. My job as the teacher right now is to teach, but also to keep you all safe. I don't know if you realize, but I am responsible for your guys' safety. That's why if we do labs, I have to go through all this safety stuff, everything like that.
Oh, yeah.
Also, Aiden, mask, please.
Wait, we're doing that now?
No. Well, I mean, like I'm saying, they measured, and every seat around Josh, they were like, yeah. So
if you're responsible for our safety, why am I about to punch stuff?
there's you gotta understand the logical limits to I'm responsible, right?
Is that why my 5th grade teacher had a bat for Code Red?
No. Well, yeah. The bat was probably Code Red is an intruder, and yes. Did you know that Did you know that on a Code Red, an intruder alert, if you have the intruder come into the room, you guys have the right and are expected to throw things at the intruder. Because that is an extreme situation where your guys' safety is threatened, and so legitimately that bat is probably their way of protecting you guys in that extreme situation, right? I guess I have a bat I should probably bring in, but I mean literally, it's a really scary thing that if that happened, that's a really big deal, but we would have the right to defend ourselves and literally throw things. So anyway, distracting. I have to try and keep you guys safe. The nurse, Miss Yakel, guys, Mrs. Yakel is working her butt off to try and quarantine kids that if they're sick, they need to be home. They can't keep spreading it to everyone else. They're working their butt off. When they quarantine you, it's a safety thing. They're trying to prevent an outbreak. They're trying to prevent you from getting sick with, this virus. So don't have, bitterness at the school for making your life hard. That's not their goal at all. It's a safety thing, but there's some difficulties that come with that. I had to do that. They told me that I had to go home for 2 weeks. No questions asked. It was like a 5-second conversation. I said, hey, I had a friend over. They just now told me they were COVID positive. And the response was, you're home for 2 weeks. Just like that. Because that's the school's policy to keep everyone safe. Let the incubation period happen to see if you actually have it. If you don't, then you're good. So I didn't have a choice. It was a pain in my butt to try and switch to virtual teaching, put everything on Classroom. It sucked not being here. I know you guys probably, hopefully didn't enjoy me being gone. It made it a little harder. It's an inconvenience, but that's our reality right now. I don't have any inside info. I have no secret info, like whispers of if we're going to, I really literally don't know anything. I'm going to know basically when you guys know if we happen to shut down or whatever. So I don't have any inside info. So I'm going to keep going. We're going to assume that things will be normal. We can still come to class and keep going until they tell us otherwise. So if we do shut down the whole school, I will adjust our class and let you guys know, hey, here's how we're going to do this. But that's if it happens. We're not going to assume that'll happen. So, all the COVID blah 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 out of the way. There is one thing that I forgot to ask you guys the other day that I needed to know. So, would it be helpful for me to have some review sessions kind of throughout these units, either before a test or maybe once a week, something like that? Head nods? Okay, what I need some input is, when would be a good time for me to do that? So a couple options-ish. Could be that once a week, in-ish, I can request y'all, you can just come down and we can have a review session during ish time. That could be an option. That's good because it's not a before-after school. Another option could be, maybe not every week, but every other week, we can have like a longer review session after school. I can say, hey, Wednesday after school today, I'm going to stay here. Any of you that want to come to the review session, just show up. We'll hang out in my class, review whatever you want, and do that after school. We're not doing before school. Way too early, even for me. I don't want to get up any earlier than 5:30, so we're not doing before school. Unfortunately, that's kind of the only two options. Give me some feedback. Like, what's your gut response for a good time to...
After school.
I like it.
I voted.
No.
Give me some hands. I need to...
All right.
Who wants ish?
Half the classroom's gone, but okay.
Yeah. Who would like to do after schools? Can I get some feedback from you guys?
John doesn't care.
John doesn't care. We can mix it up.
Do you guys have any preference?
I just did calculus my entire ish period because I met my calc teacher.
Yeah. Yeah, I don't know. I was hoping there'd be a majority.
There's not a majority of people.
I mean, fair. We're missing, 3, I think.
There's 8 people.
Part
Yeah.
of me likes the idea of having it during ish, but then again, I also do occasionally have assignments that I have to get done during ish.
Uh-huh.
Closer ish is kind of crazy.
Yeah, it is.
That was
I got like 14 kids coming in ish. Now, that's a problem because they haven't been doing their homework. So, I'm going to try and help all of them at once. We'll see how that goes. You're right, it is a little crazy. I kind of lean towards after school. I don't want to do it every week. One, it's a burden on my schedule to do once a week. We can if you want to, as long as they would be a little shorter, or we could do once every other week to kind of review stuff. Is there any feedback on that? Would you rather have like once a week for like an hour, or less, like 45, whatever, but shortish, or once every other week for like, an hour and a half, like a solid study session for, the last 2 weeks? Any preferences and feedback from that? Okay,
I like the 1 a week
one a week?
Yeah. Because like if
Once a week?
someone has something to do, they're not like
Okay,
sitting here too long.
okay, we could do once a week, right? I can do that.
Is it the long one or the short one?
Shorter ones.
Okay.
Yeah, if I do them once a week, I can't do hour and a half, 2-hour review sessions every week. I am struggling to stay afloat as it is. Those review sessions, what's going to be most helpful for you guys? My immediate thought is I would love to just answer questions. So like homework assignments. You get an assignment, you're like, oh crap, I don't know how to do this. Come to the review session, be like, Mr. H, I need help. Get us started on the homework. I don't even know where to begin. And I can work through a couple problems, solve them to get you on your way. Any topical questions like, Mr. H, I don't understand spring potential energy. Can we do some problems or review that? That's really helpful for me, for you guys to come to those review sessions and tell me what I should review. Right? I need you to tell me what you're struggling with, what you need help with, and then I can help. If not, I can try and have some backup stuff prepared, basically just reviewing the topics that we've covered, say, that week. Does that sound like a valuable use of a review session?
Yes.
Yeah? Any other suggestions? Do you have any other ideas for me that would be helpful?
FRQs, like printed out from AP.
You want FRQs?
Yeah, and then we could like work through them.
Okay. So Mag's talking about the FRQs, the free response questions.
Freaks.
Freaks. Free response questions, you haven't seen any of them yet because each one is long. It's like 3 different questions, half a paragraph answer, workout. They're long problems. They give you like one, description, and you have a bunch of questions. I can't grade those on the test. I could, but I'd have to make my test shorter because those are way harder and longer to grade. But that would also be a good one. That'd actually be really good because then we can review the topics we've learned, but practice together doing FRQs. It's a really good suggestion. Thank you, Maggie. That would also give you guys that exposure to like what the heck an FRQ looks like because they'll pop up on the test, the AP test. They disperse them throughout the test.
In calculus, we have freak of the week, so we do one every week.
Ooh, that's a good one.
That must be fun.
It is.
That's good practice. That's a good idea. I think, and I think we could do one a week, right?
Yeah.
I think that'd be good. So, like the end of the review session, or if we don't have questions, I can pull one up off my AP, and we'll work through that. I can do it like I'll show you, give you like 5-10 minutes, whatever, to do it, and then I'm like, okay, how do we do? Let's see how to do it. That's a great idea. Thank you, Maggie. Okay, so that'll be what the review sessions will look like. Come with questions, whether it be on the topics or on the homeworks. And then I'll have some generic review. We can just review topics. I can re-explain stuff. And then we'll try to like maybe end every review with a FRQ. That's a great, I think, good use of review session. Again, they're not going to be mandatory. I want you to come if you want to take the time to practice. Please don't neglect them. I want you all to be there because I think they're going to be valuable, right? It can only help. But if you got stuff going on or you're feeling really confident about the material, that's 100% your choice. Just know they're optional, but recommended. Huh?
You're like, if you're feeling really confident, if you're feeling really...
Not so good. Yeah, so we're kind of running out of time before Thanksgiving. I don't know if we can have one because we got the test next class.
Freaks on Thanksgiving. We meet on Thanksgiving.
You guys knew we got our test coming Monday, right? Today is review day.
Totally.
Next class, we have the test.
And like,
I was very clear beginning of the week, like, hey, we'll test right before break. You got time if you have that panic moment, but it's next class. Don't forget over the weekend, right? So we're done with material. The 4.3 homework was the last, subtopic of this unit. So hopefully you finish that up. Another big thing, everybody, even you guys are typically on top of it, but all my classes are really struggling.
Who's now? Who's now?
This is Mr. Heinrich.
Who's it gonna be?
Yes, this is him. Oh, okay. No.
Okay, over here.
Nice. Yourself. Okay, which student? Yep. Okay, he's absent today. Yep. Okay. Okay, those 3? Yeah, because Andre's out. Okay. I'll send them down. Thank you. Bye. Sorry, guys. That was the nurse. So Brody, John, and Trevor, they want you to head down. I don't know what it is. I mean, you could, when you go down there, you can talk to him.
Where are we going?
And then there was
Just go to the nurse. So, for you guys that are heading out, I don't know what'll happen. This recording I'm going to post to Classroom, so you'll be able to watch me review stuff. If you're on quarantine, you'll still be able to take the test, but it'll be a Google form. Again, I'm going to need you guys to have academic integrity and assume you're in class where all you have is a pencil, your calculator, and your AP review sheet. All right, I'm going to have to trust that you guys are going to be honest. Same with my virtual kids. But you'll take it all the same. It's going to have to happen before Tuesday ends. I want you to take it on Monday, same as you would normally. Just take it on a Google form. I'll post it. But if you don't get it, it has to be in by Tuesday. No further. Otherwise, it'll be a 0. Right? It has to be done before we start Thanksgiving break. Okay? All right? I don't know what they'll say.
You know what they'll say.
Maybe. This is the first time they've called kids out of my classroom to do this. But
I
They
mean,
probably
they
bring
called
other people to come grab them.
Josie out of my pre-calc class.
Really?
Since she
yeah. Yeah. Again, I'm sorry. I can't do anything for you. Yeah, let them know that.
You're like, oh no, we're like, oh no.
Because she
looked right at me. I was like, oh.
Because she was like, I got a bunch of students, and I was like, oh, so I was like trying to keep track as she was saying.
I was like,
All I know is
I'm sorry.
the virtual students are probably
Pay attention to Classroom, though, you guys. I'll post everything for you.
Number 5. This is gonna
Yeah,
be
this is
fun next few
insane.
weeks.
This is already a very small class, and now it's absurdly small.
You're the only one.
I'm the only guy.
Okay.
Now what?
Yeah, now what?
Weren't there only 4 girls in the total class and the rest are guys?
Yeah, all the girls are still here.
Survival of the fittest, I guess.
I guess. The guys are dropping like flies.
As they should.
Yes, so it's really annoying. I feel bad for him, but again, there's literally nothing I can do. It's just the way it is. So, where was I even talking about?
You were talking about
Missing work?
Something about review.
well, you started talking about
No, I was talking about missing work as a whole. The 2-week quarantine, when I was gone, all of my classes just stopped doing anything. It was a nightmare. I mean, I had like 20% submission rates. It was awful. So then when I came back, I had to tell all these kids, like, hey, you have a bunch of missing work. It's due, before we take the test. You guys are usually on top of it, but again, it might not be you, but kind of as a whole, there's a lot of you guys still missing some assignments, right? A lot of you are missing the 4.1 homework, 4.2, and 4.3 homework. That's on my AP, right? I assigned it to my AP classroom. You go in, and it's basically like, the multiple choice questions we take. It's like one of those, but really short. I don't grade you on your score. I give you completion points. If you go and do those problems, I give you points. Because I'll go in and check, I can see who did it and who didn't. So if you did it, I gave you points in Power School. The point is to practice, right? Even if you miss every single one of them, it'll show you the answers, so use that to study. Why did I miss this question? I used the wrong equation. Or rework the problem, I did my math wrong. Whatever it is. You got to look at the answers to practice. Don't just take it blindly and say, I got my points. It doesn't help you at all. What really counts is when we take this test. That being said, I also don't want to give you zeros, right? You just need to do your work. So a lot of you might be still missing things. Go to Power School, see what you're missing, get it done, because it's due next class. Remember my late work policy. Any late work can be turned in late for full points. Don't care. Get full credit if you just do it. However, that period ends when the unit ends, right? I don't give you credit for Unit 4 work at the end of the semester. We've already finished and moved on. It makes no sense. So that means if you got missing work right now, it's due next class. like when you walk in my door, do, right? Because we're going to come in, we can review a little bit, like last minute crash course, but then we got to take our test. When we take our test, that's the cutoff point. If it's not in by then, it's stuck at a 0 and I won't accept it. I don't want to give you zeros. But if you don't do anything, that's what you earn, right? You don't get points for something you don't do. So please just do your work, get it in, look at Power School, see what you're missing, go to Classroom and turn it in, or go to my AP, right? Those homework sets were done on my AP. I'll go check them and give you points for them. Any questions about missing work, or there should be no confusion on the deadline. There should be no confusion that next class, so Monday is the test, right? All the rest of class we're going to review. Any questions as a whole? Okay, I've had to say that 4 times today, all my classes, because kids still are forgetting their missing work and not turning it in. So, you guys, at the beginning, or a few weeks ago, did I print out the big ideas and give you guys each a copy of that? I thought I printed some out. It was a sheet of all of the big ideas for each unit.
I don't think you print them out. They're on Classroom.
Okay, I know they're on Classroom. I posted it on Classroom. I thought I printed them out for you guys, but I might not have. I just wanted to see if you have a copy. I want you to get it out. Otherwise, I'm going to throw it on the board. Again, it's on Classroom. Let me get this. Oh, my projector.
So every unit?
Yeah, it would be like a 2 or 3 page thing, maybe a few more, but it has each, like half a page big ideas. Yeah, you might have it separated, like front or back. No? Okay. Okay, that's fine. I literally didn't know, but if you had a hard copy, I wanted you to get it out. Otherwise, I'm going to throw it up on here. It's always sitting on Classroom, right here. So you go to Google Classroom. Down at the bottom, I have a bunch of generic, big ideas, the lab notebook, whatever. The AP equation sheet, I got a PDF of that in case you ever lose it. Schedules, I don't know what that is. Oh, that was literally like, what's our 2-hour delay schedule? But what I want to go through is this big ideas document. We're going to start with a high-level overview of all the topics that we've talked about, right? I want to review these topics with you. And please, if you have questions, you've got to raise your hand and tell me, right? You guys are a really quiet class, which is kind of unfortunate, because I can't tell what's going on in your heads. It's either we literally have no questions because we get it. Well, that's awesome. Or it might be I don't want to say anything. Or it's I have a question, but I don't want people to think it's a stupid question. All that's baloney. I don't like that because it prevents me from understanding where you guys are at. It prevents me from doing my job and helping you learn. So please, shout out questions if you got them as I'm going through this. I want to start with energy. We had 3 topics. So again, I'm working on finding time to post this. But Unit 4, we first started with open and closed systems, right? When you define a system, you basically draw an imaginary line around what you call your system. Everything inside that system is what you consider, what you're investigating. You can define the system differently and you get a different answer, right? If I push on an object and I include the block and myself, everything is in my system. But if I only look at my system as just the block, there is some outside force coming into my system. Because I said my system was just the block. So your system can change your answer. A lot of times your AP questions will ask you, like, consider the, ball and earth system. How much energy does it have? Well, you have to think about energy in the total, the earth and the ball. How much energy is inside there? It can change your answer. What is an open system?
Anything can go in or out of it.
Bingo. It's open. Like anything, so matter, you can have objects go in and out of a system. They can leave the system or enter it. What else can go in or out of the system? Energy. The energy is not constant in your system because it's an open system. Your energy could leave the system, so now you have less than you started with, or energy could come into your system, right? That's an open system. It's open to anything coming or going. What's a closed system? There's three systems: open, closed, and isolated. You guys remember the differences? We talked about open. Matter can go in or out, and energy can go in or out. What's a closed system mean? What? Yes, right? Can we confirm that? Do we all agree? That closed system is where what'd you say? Matter can leave? No. You said it differently this time.
Matter can't leave the energy.
Yeah. Can you check in the textbook, Sierra? I want to make sure we don't miss this. Yeah, you said it differently both times. I was confused. Yeah. That's good. But I want us to make sure we confirm. Does your textbook have any definitions? I want us to make sure we're on the same page. Does not exchange matter with its surroundings. Right? So closed system. You can't have objects or matter go in or out. But you could have energy. An isolated system is 100% isolated. No mass can go in or out, and no energy could go in or out. Right? That's important to know. That could change your answer if they say, hey, this is a closed system. Or this is an open system. What happens in this situation? So that was that first subject. And also, when sometimes you get to define what the system is. You get to draw the imaginary line or the imaginary boundary and create a system and investigate that system. So sometimes you have to stop and think, what system do I need to consider? Well, my objects include this person, the ball they're throwing, and the earth. That is what I'm going to define my system as, and that's how I'm going to do my problem. Okay? So that's the first topic. Where is that at? Yeah, here. Second topic, we got into the nitty-gritty. This was all about work and energy. So, I want to go through these. You guys remember what work is? What's the equation for work? You should know it. Can you still see it?
Yeah.
A little bit, but barely.
Dang it.
No matter where you hold up, it's still gonna be there.
Hold up a whiteboard.
That's not very visible. Anyway, What's the work or equation for work? Force times distance times cosine theta. Does everybody see that? Everybody know that? Crucial, huge part of physics and energy itself. Work is force times distance. The full equation that I would recommend you use every single time is force times distance times cosine theta. What is the theta? What angle are they talking about? Shout it out if you know it.
No, I know, but I don't know.
An angle is between, two things. What angle are they talking about? It's crucial that we know this, because otherwise you can't use the equation. Okay, stop and pause. Look at the equation. What variables are in that equation? F and D and cosine theta. So, doesn't it make sense that the angle has to be related to those? That's why it's in that equation. Yep. Can force have a direction?
Yeah.
It absolutely does, always. The displacement. Doesn't your displacement have a direction? Am I displacing 5 meters this way or this way? It has a direction. This angle is the angle between the force vector and the displacement vector. What is the angle between a force applied, right? If I got my car, I don't know if they'll be able to see this. All right? I have my cart. I'm applying a force this way. This is the direction of my force. If I push the cart, what direction is it going? How am I displacing it? What's so funny?
Just a video to me.
A mirror of the same thing?
Slightly delayed too.
I don't know what
It
else.
could just be me. I don't know.
Here. There. Alright? If I push this way, where is my displacement pointed? It's not a trick question. This way. If I'm pushing this way and it's displaced this way, what's the angle between those two vectors? What's the angle between these two vectors? 0. It's not a trick question. They're literally in the same direction. There is no angle. Well, what's the cosine of 0? It's 1. Then you go to your generic equation, force times distance. Right? You guys see that? That's why I would say always use this. Even if they're in the same direction, just put the angle as 0 and make the equation do the work for you. Now, what happens if I push the cart, but the cart somehow moves backwards? The force is going this way, the displacement is going this way. What's the angle between the force vector and the displacement vector? 180, right? 180 degrees. The cosine of 180 is -1. The force times the distance covered times -1 gives you negative work. What that means is as this object's moving, I'm doing negative work on that object. I'm pulling energy out. Does that make sense? Work is, or actually energy is the ability to do work. So if you do reverse work, you're doing reverse energy, meaning you lose energy. That's really important to understand. You can use your equation, plug in the math, get your angle. It'll give you a number, but you have to understand if I get a negative number, a negative work, I have to understand that means energy is leaving my system because the force is doing opposite work against the motion, So I'm doing work against the object. Basically, you would be slowing it down in this situation, right? Cart's coming this way, and I touch it, and I start slowing it down. I'm pushing, but it's moving this way. I'm pulling energy out. Well, eventually, I'm going to stop it because I sucked out all the energy because I did negative work, right? Does that make sense? Am I beating a dead horse, or is this helpful to have me explain this? It's helpful?
It's helpful.
Okay, good. Right? I don't want to be talking about this if you're like, yeah, Mr. H, we get it, move on. But I want to be very thorough in explaining these key concepts. You know the equation? Is it on your sheet? It's another thing, you got to know what's on your equation sheet. What resources do you have?
It should be.
It's a bit of a mess, honestly. I don't like how they organize it. Yes, it's on there. There's an equation kind of in the middle. The change in energy equals work, which equals, if your force and displacement are parallel, it's just FD, or FD cosine theta. You get this equation. You just got to know what it means and how to use it. All right? Here's something that I haven't said, but you should be able to figure out. If my work is positive, what happens to the energy of that system? If I do positive work on this cart, what does that mean about the energy of the cart? Does it go up, does it go down, or does it stay the same? If I do positive work,
Doesn't it go up?
it goes up. Bingo, I just told you negative work means you're pulling energy away from the system. If I do positive work, I'm putting energy into this system and speeding it up. It's getting more kinetic energy because I'm doing positive work. Okay? A lot of this stuff I might have said already. Force in the same direction as the displacement is positive work. I just said that. Increasing energy. I just said that. Okay? If the force and the displacement are in opposite directions, you have negative work. Your equation will literally give you a negative value. That's decreasing energy. You're removing energy from the system because you're doing negative work. All right? Again, I'm not trying to beat a dead horse, but super important. Big, big concept in kind of the rest of what we're doing in this energy unit. The units of work are the same as the units of energy. How do we measure energy in science class? What's the unit called? We should know this. All energy is measured in the same unit. What? Maggie said it. Joules. That should ring a bell, right? Joules. You have to know that. Joules is the unit that we call it, but you can break it down. If work is measured in joules, because work is doing energy in or out, these have to be in units of joules. Well, what's a force measured in? Newtons, right? How do we measure displacement in our science class? What's the unit for displacement or distance? Come on, this is easy. We've done this for weeks. How do we measure distance? What's our main unit? You had it. It's on the tip of your tongue. No, just the unit. Come on, guys. Shout it out at me. Yep. Or distance. How do we measure it in inches, miles?
Meters.
Meters. Thank you. We have to know this. That's the base unit for all distance. All of our equations use the base unit, so meters, and then newtons. A newton is a kilogram meter per second squared. So then a joule is a kilogram meter squared per second squared, right? You can do your base units, but the main thing is energy is in joules or Newton times meter, right? Force is in Newton, distance is a meter. The cosine is no units, so a Newton meter. A Newton meter is the same thing as a joule. And then the base units, the simplest you can go is kilogram meter squared per second squared. Big thing, remember a joule. Work and any form of energy is measured in joules. Okay? Work is the area under a force distance curve. This is something that we haven't talked about explicitly. I want to pull up a graph to show you that this is true. This is pretty simple, but I want you to see why it makes sense graphically. What was the equation for work? FD, right? Force times distance. If I look at a graph of the force applied over the distance that it travels, this is the displacement. This is the total force applied at any given moment in time. So this force was applied over this displacement. Well, the area under the curve is force times displacement. The area of this box is length times width. Force times displacement. Force times displacement is work. That's why the area underneath a force distance curve or graph is equal to the work. The area under the curve is a length times a width, force times a distance. That's exactly what our work equation says. Sometimes they will give you a graph and say, how much work was done on this object? You're like, well, crap, I don't know. I need to know force and distance. It's right here. Force, distance. That is how you can get work from a force distance graph. I don't know if that's popped up, but it's fairly straightforward, but you got to know because they will sometimes ask you this. Does that make sense why? The area under the curve is length times width. Well, it just so happens that our length is a force, our width is a distance. Force times distance, that is the definition of work. They're the same thing. Okay? All right, so let's go back. Keep going. Power. Who knows what power is? Describe power to me. You guys remember it? It's related to work. It's also related to time.
Isn't it the change in work and then the change in time?
Bingo. Power is the change in work over the change in time, right? How much work do you do in a certain amount of time, right? I can walk around, or let's say, I can walk from one end of the room to the other. That's me applying a force to walk for a certain distance. It's a set amount of work. Let's say it's 100 joules. If I walk across the room, but Aiden runs across the room, who gets there first? Aiden. It takes him less time to do the same thing. Well, wait, we did the same amount of work. We both pushed our bodies the same distance. We did the same amount of work. Who had more power? Power is the work you do in how much time. Who took less time? Aiden. He had the same amount of work divided by a smaller time. Let's say it took him 2 seconds. 100 divided by 2, that's 50 joules every second. If it takes me 10 seconds, I did the same 100 joules of work, but it took me 10 seconds. I only get 10 joules per second of power. It takes me longer to do the same thing. That's what power is. Power is also the change in energy. Work is a change in energy. Remember when I did work on the cart? When I do work on the cart, I'm adding energy. Well, you can also look at how much power was I delivering, right? If I speed the cart out to a certain distance, but I do it like this, and it reaches a certain amount of kinetic energy, or if I go like this, I basically do it faster. I delivered more power the second time because I took less time. Remember? If you decrease the denominator, you increase the overall number. Does that make sense? It's also why your cars, they measure them in horsepower. That's an English unit for power. Which car can accelerate faster? A car with 100 horsepower or a car with 500 horsepower? 500 horsepower. It can get up to 60 mile an hour, the same speed, much faster because it has more power. It can do work faster. That's what power is. How quickly work is done, or how quickly you can expend, either add energy or take it away. Does that idea make sense? Work is a force times distance. It's a change in energy. Positive work is putting energy in. Negative work is pulling energy out of my system. The power describes how fast I can do that. More power means more energy in a shorter time, or I can pull more energy out in a faster time. So power is work over time or energy over time. The change in energy. Okay? Any questions about power? I don't know if that one's on your equation. I would doubt it.
I think it is.
Really?
Yeah.
It is. P equals delta E over delta T. You get this equation.
Yeah.
So you got to remember, hey, this is talking about power, and it's saying how much energy can you change, input or output, and how much time. Okay? So that's good. Power is measured in watts. That's our science class unit for power. It's joules per second. Some people actually leave it as joules per second, but it's the same thing as a watt. All right? Energy. Energy is the ability to do work. If you have energy, you're able to do work. Because work is either putting energy in or taking it out. I need energy to do work on anything. Change in energy is equal to work. If I know how much work was done on a system and it was positive, I know how much energy was put into that system. If I know my system lost energy, I know negative work was done because that energy had to come out somehow. Gravitational potential energy. This is our MGH equation. Remember, we have three types of energy. We have gravitational potential energy, kinetic energy, and spring potential energy. First one, gravitational. I always do MGH, where H is the height of the displacement. They often use a delta Y, right? You started here and ended here. That change is H, or delta Y. So your energy is MGH. You could measure the energy, or this is the change in energy. If I start here and end here, I started with this much potential and ended with that much, so my change in potential is mg delta y. It's relative to the ground. We always say, or should always say, that the ground is zero potential energy. You can change that depending on your system, but you've got to be consistent for that problem. Normally we say the ground, that's 0. If I'm on the ground, I don't have any gravitational potential energy because my height above the ground is 0. Right? Kinetic energy is a big one. Now, I can't block it. You know the equation for kinetic energy? Is it even blocking it? I'm trying to make it obscure shape so that you can't You guys need to know this. Is this one on here?
I know part of it.
It is on here. You don't need to memorize it, but you have to know how to use it. What part are you talking about?
I know part of the equation. It's like 1/2
Yep.
something v to the second power.
Exactly. M, mass.
M.
1/2 mv squared. 1/2 mv squared. That is the equation for kinetic energy. 1/2 times the mass of your object times the velocity squared. They'll try and trick you. They'll say, oh, you double the velocity. How does your kinetic energy change? Kids say, oh, it's doubled because I've doubled the speed. Wait a minute. You doubled v. You have to square that. What's 2 to the second power? 4. You would quadruple your energy if you double your speed. They're going to ask you tricky questions where you just have to use the equation. Kinetic energy is the energy of motion. That means the more mass your object has, the more kinetic energy you have, because m goes up. And if you have more velocity, your kinetic energy goes up exponentially to the second power. Right here, if you double velocity, k is quadrupled because you take 2v squared. That turns out to be 4v, so you have the whole thing times 4. If you triple your velocity, 3v is 9 times v, because I have to square it. Don't let that trick you. They'll ask you this. They want you to say, oh, you double speed, you double energy. No, you got to look at the equation. That's not true. This gets into conservation of energy. If you drop an object and it loses 10 joules of potential energy, if you lose potential energy, that energy has to go somewhere. Well, it goes into kinetic energy, right? When you drop something, it starts to speed up. Now you got kinetic energy. Well, the way it got that kinetic energy is gravity did work on the ball, say that you drop. Because you have a bunch of potential energy that switches into work, it does work on the ball to give it kinetic energy. Your total energy is conserved, though. There was nothing that went in or out of the system because you had the ball and the earth. It's just your energy switched. You guys remember that skateboard lab simulation? When the skateboard is at the tippy top at a standstill, he has no velocity, so there's no kinetic energy. There's no spring, so he doesn't have spring energy. All his energy is what?
Potential.
Yes, it's all potential energy. That potential energy, gravity is starting to pull him down. That energy is used to speed him up. At the very bottom, you're on the ground. You don't got potential energy anymore. What do you have? Kinetic. You picked up a bunch of speed and you have a ton of kinetic energy. Well, then you start going up. Gravity starts slowing you down and taking the kinetic energy and switching it into potential. And then it just keeps going back and forth. Because in that system, everything is conserved. So, this is exactly what I just said. Potential energy at the top of, let's say, a hill is equal to the kinetic at the very, very bottom, unless there's work done. Right? If you have friction in your skateboard wheels, it sucks energy out. It makes heat and shoots it off into space. So you are losing total energy. That's why you eventually stop. If you didn't have friction, you would constantly go like this forever. Because your energy doesn't leave. but the friction does work and sucks energy out, so you slow down. Potential energy, of a spring. You'll often see it as U sub S. So on your equation sheet, U sub S, 1/2 kx squared. Do you remember K? What does K mean in that equation? Yes, this is spring energy. It's how it's the spring constant. It's how stiff your spring is. If you have a really stiff spring, it takes a lot of energy to squish it, right? That means it's going to shove a lot of energy out. This is a big number. If I squish a spring a lot, that X is the displacement. If you let a spring sit on a table, that's its natural length. That's what its resting point is. However, I change that, the distance away from my resting position, my natural length, is X. I compress a spring, I put energy into that spring, right? I did work. I pushed the spring over a distance. I did positive work on the spring. That means I put energy into the spring. Where did that energy go? It's stored as potential energy. What happens when I release my hand? What happens to the energy that I stored up in the spring? Spring goes back to its natural length. This potential energy gets converted into kinetic. It'll shove whatever is against it away until it goes to its natural length. Now in real life, it'll oscillate and then stop. But when you consider it, it'll shoot something away until you at your natural length, and then it lets the object go. All that potential energy was released. It did work on the object and say push the object, right? A pinball machine. How do you start a pinball machine?
You pull something back.
You pull the spring back and let it go. You compress the spring, and it's got the little pinball. When you let it go, that spring releases its energy and goes back to its natural length. In doing so, it shoved a ball and converted all its potential energy into kinetic. The ball now has a bunch of energy, and that's how it goes into your pinball game. Aiden, question.
Okay, this is a fun one. But what if the spring breaks? Then where does the energy go from that?
Like it breaks when you compressed it? Like you compress it and it snaps?
Compress it, it snaps, or extend it, like which just when it breaks?
It depends on what point it breaks. Like if you compress it and it snaps, the energy is going to like fling your spring parts outwards. So the energy is conserved, but it just like blows spring pieces outwards rather than in one direction. If it's going and snaps, the energy is still there, but it just gets cut off. So it just continues to shove things. So energy is still released, but you won't have to worry about that situation, right? You won't worry about a spring breaking. It's just releasing its energy. Okay? That's Hooke's law, right? Stopping distance. This is a good one. You can find the energy in your car by doing like a stopping distance test, right? Your car going 1 mile an hour, it has a certain mass, it's got energy. If you hit your brakes, how much distance does it take to stop your car? AKA, how much energy do you have to take out of your car to get it to stop? Well, how do you put energy in or out of a system? How do you put energy in or out of a system? What do you have to do on that system? Work. You have to apply a force over a distance to change energy. Your brakes do the work. You can calculate that. The stopping distance, if you know the kinetic energy, the mass and velocity of your car, you know how much energy it starts with. You can measure how long it takes to stop your car, and then back calculate. I lost all my energy. That was the work done. I knew it took this distance. What force had to be applied So you can calculate work or the friction. That's a common example they might throw up there. This is something we didn't talk a ton about. This is like gravitational potential energy. So if you look on your equation, there's U capital G. It's on the very, very bottom. This is because if you have two planets, remember our universal gravitation? They're attracted to each other. There's some force they're pulling each other together. Well, the potential energy there is if you let that planet go, that force would pull that object together over a certain distance. That's energy. So the potential energy is looking at how strong your gravitational force is times the distance that they compress together. I also want you to look at your equation sheet. The potential energy is how much work it could do. Work is force times distance, isn't it? The universal gravitation, remember, G times m1, m2 over r squared. That's the force of gravity. If they come together by a radius. Well, G m1, m2 over r times r means the r's cancel. That's where you get this. I want you to see this. Right here. This is the force of universal gravity. This is F times D is the radius between them. What happens if I multiply this by R? R divided by R squared means you just have an R at the bottom. That's where they got this. Universal potential gravity is just G, M1, M2, R. That is on your equation sheet. It's negative, right here, the amount of potential energy lost. That potential energy you lose when they come together. The work done, it's negative work. It comes out of the system. Now they're closer, they have less potential energy. Okay? We did this. And then at the Earth's surface, an object will not have UG, let's see. Yeah, U little g is what we say. If an object is on the Earth's surface, we say it has zero potential energy. MGH. Your height's 0, so you have 0 potential energy. However, aren't you still a certain distance away from the center of the Earth? The Earth still is trying to pull you to the center. You still have a distance away. You still have gravitational, like the universal potential energy. Because there's still a potential for you to get closer to the center of the Earth's mass. It's a weird kind of nuance. But we almost always use U little g, MGH. If that's the case, on Earth's surface it's 0. You're 0 meters above the Earth. However, if you look at the universal gravitation, U capital G, there's still a radius, right? I'm still a certain distance from the Earth's core. There's still a potential for the Earth to pull me down. Okay, I didn't leave as much time as I thought. Any burning questions after going through all those big ideas? Sierra, what's up?
Do you always have to use the cosine
In the work equation?
Yeah.
You don't have to. I recommend it because that way every time I use the same equation, I plug it in and let the math do the work for me. However, if you know that your force and displacement is in the same direction, you know cosine of 0 is 1, so you only would have to do force times distance. If you know the force and displacement is exactly opposite to each other, you know the answer is going to be a negative answer. So you can just know force times distance is going to give me a negative answer, right? So you don't always have to. If there's any angle other than 0 or 180, you do need the FD cosine theta. Because otherwise you can't do trigonometry, mental math in your head. You would have to use the cosine theta. I recommend using the cosine theta every time, because if it's the same direction, you plug in 0, make sure you get the right answer. Or if they're opposite, you plug in 180, it tells you it's negative, you're good. But you don't have to, as long as you remember, oh crap, they're in opposite directions, so my F times D really is a negative number, because it pulls energy out. So not always, but it's up to you. My personal preference, I always use FD cosine theta. Just because I plug in what I know and I let the equation do the work for me and tell me the answer. So that's my recommendation, but however you do it, 100% to you. Other questions? Was this okay? Was this helpful?
Yeah.
I wasn't boring you. If I was, tell me. Like, Mr. H, this is pointless. Like, I don't get anything out of this. But this was helpful. Hopefully a good reminder. Hopefully if you didn't quite get things, hearing it another time right now helped you understood it. Either virtual or quarantine students, I hope you please watch this. A lot of my other classes, my kids don't watch videos at all, and they're completely lost because they never see me teach, because they choose not to watch videos. So I hope you watch this to, again, hear this review over these key concepts. See if there's any other big topics that I missed. Oh, mechanical energy. Remember hearing that term, mechanical energy? What is that?
All of the energies combined.
Yeah, mechanical energy is basically total. So think of those as synonymous with each other. The mechanical energy of a system is the total energy, meaning sum of your potential energy due to gravity, UG. Sum of your spring potential energy, U sub S or U sub E, however they write it, plus the kinetic energy. All those three things added together equal the mechanical energy, aka total energy of your system. If no forces act on your system, what do you know is true about the mechanical energy before and after something happens? You have a system, no force acts on it, no mass leaves it. What's true about the energy to start with and end with? Are they the same energy? Did the energy go up or did the energy go down? Same. The law of conservation of energy says energy is conserved unless work's done. If you have no work, no force acting on your system, you kind of think, well, how could energy possibly leave? It just gets converted from one thing to another. Remember her LOL diagrams in the video? She said you have potential energy, and that's it. So your mechanical energy you only have potential. On the end, it got converted into only kinetic energy. The total mechanical energy is exactly the same as you started with, but your energy just switched from one form into another, still inside the system. What happens to your mechanical energy if work is done on the system? Does your energy stay the same? Does your energy increase or decrease? If it's positive work, it increases. Right? If you're on that skateboard example, you go to the very top and your friend shoves you back down. That's an outside force acting on your system. Work times a distance is a change in energy. My total mechanical energy for that system increased. Right? Now I have more potential energy. Right? That's what you do when you, remember on a swing, when you pump your legs? You're doing work and increasing your energy so that you can swing higher. Right? When you do work, you increase or decrease the mechanical energy. If you do negative work on a system, what happens to the total mechanical energy? I do negative work on my system. Does my total mechanical energy go up, stay the same, or go down?
It goes down.
It goes down. Negative work is pulling energy away. The total energy in my system is decreased because negative work happens. Good. That's talking about conservation of energy, the work energy principle. When work is done, you change the total amount of mechanical energy. And we talked about power. I think that's it. That's the main topics that I got listed. Any other overall questions, stuff that still doesn't make sense? Okay. I'm sorry I don't have time to do some practice problems. Again, your 4.1, 4.2, and 4.3 homework are going to be really good practice, right? Even if you didn't get them all, look at the answers and try to rework them, figure out what you went wrong. Again, I haven't written the test yet. That's what I have to do this weekend. I'll try to keep it the same as last test in terms of length and stuff. I'm going to try to find that balance between, not as insane as an AP test, but not, a joke, because that doesn't do you any good to prepare for the AP test. I'm going to try to find that middle ground. What's that? Perfectly balanced. I will try. Again, I will work on setting up the review sessions. Unfortunately, we don't really have time. To do one, because we got the test Monday, and then we got Thanksgiving break, which is awesome. Yeah, there. It's getting kind of crazy. Who's excited for Thanksgiving break? I'm really excited. Right? Hopefully you guys rest and actually take a break. I'm not going to assign any homework. I might have you read the very first introductory section. Maybe do it right before you come back to class that next Monday, just so you have some exposure to our next unit. But it would be easy. It'd be a couple pages. But that could be literally the night before. Just get your brain back to thinking about physics, and then we can talk about it. The rest of this semester, we are looking at, we're going to finish the next unit, which is Unit 5, which is about momentum. That one, we're on track to schedule, or to end right before we go to Thanksgiving break. Winter break. Christmas break. So the next 3 weeks after we come back from Thanksgiving will be all about momentum. We'll try and end before break. Maybe have a free day where we can talk about the AP test, kind of start planning for second semester, but also have some hangout time to just chill and do something fun, give you guys a break. All right, so that's the game plan for finishing up this semester. Keep in mind, get your missing work in. Please get that done before we come to class Monday. Be studying for this test. Review the big ideas. Review your homeworks. Review the work, power, energy worksheet that we did. That's a really good one to practice, work calculations and energy calculations. What else is on Classroom? The skate park energy lab. That was another good one about energy conservation. You could rewatch the daily video ones if there's a topic you're like, I don't really get the work energy theorem. Go watch those videos to practice. Other than that, I'll sort of be on my email. I have a lot of work to do, like your test and stuff, but I'll try to look through emails. So if you have questions, like on a topic, like shoot me an email and I'll try to get to it as soon as I can. But then we'll see you Monday for the test. Any other burning questions? No? Okay, I will shut up and stop talking. Pause this. Again, virtual and or quarantine students, you will have to take this test all the same. I'm going to put it as a Google form. You're going to have to take it ideally on Monday, the same as you would if you were still here. But it has to be submitted before you go to Thanksgiving break. So like Tuesday, 2:30 p.m. cutoff point. You have to get that test done before break so that I can grade them and we can get ready to go on Unit 5. Please don't miss the test. Do not forget if you're a virtual student. I don't want you to have a 0 for a test. It will not bode well for your grade. Get your missing work in. Let me know if you have questions. Yeah, that's, I think, the last thing before I pause.